Hello, Math 20-2s. Today we're going to determine the roots of a quadratic equation. Alright, so in this lesson we're going to introduce an application of factoring, namely the solution to quadratic equations. Alright, so let's investigate the zero product law. Complete the following. The equation x minus 3 equals 0 is true only if what happens? There's only one number that makes this true. Add 3 to both sides. That only works if x equals 3. The equation x plus 1 equals 0 is only true if x equals minus 1 from both sides, so negative 1. Therefore, the equation x minus 3 times x plus 1 equals 0 is true if, well, here x can equal 3, we just did that up there, or here x can equal negative 1, we just did that right there. So it's only true if x is 3 or if x is negative 1. Doesn't matter. As long as one of these brackets is 0, 0 times anything will give us 0. The equation 2 times x minus 3 times x plus 1 equals 0 is only true. Again, this non-variable factor isn't going to affect anything. It's only true if x is 3 or x is negative 1. Last bullet, the equation 2x times x plus 1 equals 0 is true if, well, this is a variable factor, 2x. So what value of x is going to make 2x equal to 0? Well, that's true if x equals 0. 2 times 0 is 0. 0 times anything is 0. Look at the second variable factor, x plus 1. That is 0 if x equals negative 1. So this equation is true if x is 0 or if x is negative 1. The zero product law then states, if the product of multiple factors is equal to 0, then at least one of the factors must be equal to 0. So complete the following. If a times b is 0, then a can equal 0 or b can equal 0, or a and b can both equal 0. So at least one of them has to be 0. They could both be 0. All right? So complete the work below to show that the zero product law can be used to solve this equation. 2x plus 1 times 3x minus 7 equals 0. So that means 2x plus 1 can equal 0, or 3x minus 7 can equal 0. Either of those are 0, the equation is going to be true. So I solve this simple equation. I minus 1 from both sides. There we have it. Divide both sides by 2. So x can equal negative 1/2. Over here, I'm going to add 7 to both sides. So 3x could equal 7. And then I'm going to divide both sides by 3. So x could equal 7/3. So x could equal negative 1/2 or x could equal 7/3. Verify. When x is negative 1/2, make sure this is true. So you plug in negative 1/2. 2 times negative 1/2 plus 1. 3 times negative 1/2 minus 7. 2 times negative 1/2 is negative 1. Negative 1 plus 1 is 0. 3 times negative 1/2 is negative 3/2 minus 7. Negative 3/2 minus 14/2 should be negative 17/2. 0 times negative 17/2 is still 0. All right. Verify when x is 7/3. So the left side says I've got 2 times x, which is 7/3, plus 1, multiplied by 3 times 7/3 minus 7. So if I work this out, 2 times 7/3 is 14/3, plus 1, which is 3/3. And over here, 3 times 7/3 is 21/3 minus 7. So to simplify, 14/3 plus 3/3 is 17 over 3. Multiply that by 21 minus 7 is 7 minus 7. Well, 7 minus 7 is 0. So I've got 17/3 minus 0. Or sorry, 17/3 times 0 is indeed 0. So it doesn't matter which bracket is 0, as long as one of them is 0, that equation is true. An equation is solved by stating the value or values for the variable which make the left side and the right side equal. These values are said to satisfy the equation. Values of the variable which satisfy the equation are called the roots of the equation. The roots of the quadratic equation, last example, are negative 1/2 and positive 7/3. Consider this equation, x minus 2 times x minus 4 equals 0. This is true if x equals 2, 2 minus 2 is 0, or x equals 4, 4 minus 4 is 0. Notice we use the word or because x cannot equal both 2 and 4 at the same time. However, since the equation is satisfied for both x and 4, we say that the roots of the equation are 2 and 4. All right. The required work for solving an equation or finding the roots of an equation is shown below. Solve the equation x minus 2 times x minus 4 equals 0. Well, so you set each variable factor equal to 0. X minus 2 can be 0 or x minus 4 can be 0. You solve those simple equations. You get x is 2 and you get x is 4. Then you state the solution, x is 2 or 4, or you can say x equals 2 and 4. Determine the roots of the equation. It's the exact same thing. All right. Finding the roots, finding the solution, they mean the same thing. The roots are 2 and 4. The solution of the equations are 2 and 4. So solve the following equations. Take each variable term and set it to 0. So x minus 7 can equal 0, or x plus 8 can equal 0. And those are very simple equations to solve. Add 7 to both sides, so x equals 7. Minus 8 from both sides, x equals negative 8. Those are our two solutions. X equals 7 or x equals negative 8. Over here, set each factor equal to 0. All right, so x can equal 0 or x plus 10 can equal 0. Well, that's already one solution. X equals 0. The other one I have to minus 10 from both sides, so x equals negative 10. So there are your solutions for this quadratic equation. Determine the roots of this equation. We do the exact same thing we did up above. Set each variable factor equal to 0. So 2x minus 5 can equal 0, or 3x plus 2 can equal 0. Solve these, add 5 to both sides, and then divide by 2. So x can be 5 halves. Over here I'm going to minus 2 from both sides, and then I'm going to divide both sides by 3. So x can equal 5 halves, x can equal negative 2/3. All right. Solving quadratic equations written in general form. So consider the equation x squared minus 9x plus 20 equals 0. In order to determine the roots of this equation, we are first required to factor the left side. We can factor by inspection, we can factor using difference of squares, we can factor using decomposition. That's what we've been doing for the last two classes. Always remember to remove a common factor first if needed. So let's complete the work below. X squared minus 9x plus 20 is 0. In order to solve this, I have to factor the left side of this equation. Well, this is a simple trinomial, so I can factor using inspection. 1 in front of the x squared, so the only way to get x squared is x times x. What two numbers have a sum of negative 9 and a product of 20? So things that multiply to 20 and add to negative 9 are minus 4 and minus 5. So x minus 4 times x minus 5 are the factors of x squared minus 9x plus 20. Now if the whole thing equals 0, I'm going to set each factor equal to 0. So x minus 4 can equal 0, or x minus 5 can equal 0. And then solve each of these simple equations. X can be 4, or x can be 5. So we say the roots of this quadratic equation are 4 and 5. Solve the following quadratic equations. This first one's a simple trinomial on the left side, so I'm going to factor using inspection. Remember, it equals 0. The only way to get to x squared is to put an x in the front of each bracket. Ask yourself, what two numbers have a sum of negative 5, a product of negative 14? So those two numbers are minus 7 and positive 2. Negative 7 times 2 is a negative 14. Negative 7 plus 2 is a minus 5. I'm done factoring. Now I'm going to use my zero product law. Set each variable factor equal to 0. So x minus 7 can equal 0, or x plus 2 can equal 0. And solve these equations. Add 7 to both sides. Over here I'm going to subtract 2 from both sides. So my solutions are x equals 7, x equals negative 2. All right. Same thing for part B. 4x squared minus 25 is 0. Well, this is a difference of squares. They're both perfect squares, so I'm going to factor using difference of squares. Perfect square root of 4x squared is 2x. That goes in the front of each bracket. Perfect square root of 25 is 5. That goes in the back of each bracket. Make one positive, make one negative. I'm done factoring. I now set each factor equal to 0. So 2x plus 5 can equal 0, or 2x minus 5 can equal 0. And solve these equations. Minus 5 over here from both sides and divide by 2. Over here I'm going to add 5 to both sides and divide by 2. So my solutions are negative 5 halves or positive 5 halves. All right. Part C. Well, I see a common factor here of 10x. So I divide both terms by 10x, and that leaves me x minus 9 equals 0. And now I'm done factoring, so I set each factor equal to 0. So 10x can equal 0, or x minus 9 can equal 0. Over here, divide both sides by 10, and I get x is 0, not 10. Divide by 10. 0 divided by 10 is 0. Over here, I add 9 to both sides, so I get x is 9. There are my solutions. X is 0 or x is 9. And let's look at the last one. 10x squared minus 90. Well, again, it's got a common factor of 10. That leaves me x squared minus 9 equals 0. Well, I can factor what's in the brackets as a difference of squares. So the perfect square root of x squared is x. That goes in the front of each bracket. Square root of 9 is 3. That goes in the back. Plus 3 minus 3. All right. Now, 10 is not a variable factor, so I don't have to worry about it. I just use the variable factors, x plus 3 and x minus 3, and set those equal to 0. X plus 3 can be 0, or x minus 3 can be 0. So here, x would equal negative 3. Here, x would equal positive 3. There are our two solutions to that quadratic equation. All right. Note, when solving a quadratic equation by factoring, the quadratic equation must have all the terms on one side of the equation and 0 on the other. It's usually easier to factor the coefficient of x squared it's usually easier to factor if the coefficient of x squared is a positive value. So determine the roots of these equations. Well, you can't just go ahead and set each factor equal to 0 because this whole thing doesn't equal 0. So in this situation, we have to expand out the brackets, get a quadratic expression, and then set it equal to 0. So this is going to be x squared minus 4x equals 5. Now I have to minus 5 from both sides of this equation, so I get x squared minus 4x minus 5 equals 0. Once I have the equation equal to 0, now I can factor it and solve it using the 0 product law. All right. So it's a simple trinomial. There's a 1 in front of the x squared term. Make your two sets of brackets. Remember, it equals 0. And the only way to get to x squared is to put an x in front of each bracket. What two numbers have a sum of negative 4, a product of negative 5? Those numbers are minus 5 and plus 1. Right? Negative 5 plus 1 is negative 4. Negative 5 times 1 is negative 5. Now set each variable factor equal to 0. So x minus 5 can equal 0, or x plus 1 can equal 0. And solve those simple equations. Here, add 5 to both sides. Here, minus 1 from both sides. And our solutions are x equals 5, x equals negative 1. Part B. Again, before I can solve a quadratic equation, we have to let this thing equal 0. So now I've got a negative 3x squared here. I'm going to add 3x squared to both sides. So I'm going to put the 0 on this side this time. So I add 3x squareds to both sides. I get 3x squared minus 13x minus 10. Well, this is a complex trinomial. We haven't factored one of these and solved it yet. But we have factored many complex trinomials before. So let's go through that method of decomposition. What two numbers have a sum of that middle term, negative 13, and a product of the first times the last, which is negative 30? So the two numbers that multiply to negative 30 add to negative 13 are minus 15 and positive 2. So we're going to use those two numbers and decompose the middle term. Remember, this is an equation, so 0 is going to equal all this. We keep the first term, 3x squared, the same. Decompose negative 13x using negative 15 and 2. So I'm going to write down minus 15x plus 2x, and minus 10 stays there. I'm now going to factor the right side of this equation by grouping. So 0 equals, the common factor of the first two terms here is a 3x. That leaves me x minus 5. The common factor of the last two terms is a positive 2. That leaves me x minus 5. I still have an equation, so 0 equals, I've got a common binomial factor of x minus 5. That leaves me 3x plus 2. So step 1, I set this equation equal to 0. Step 2, I factor my complex trinomial, and I get x minus 5 times 3x plus 2 equals 0. I now set each variable factor equal to 0. So x minus 5 can equal 0, or 3x plus 2 can equal 0. As long as one of those is 0, this equation is true. So here I'm going to add 5 to both sides. Over on this side, I'm going to minus 2 from both sides, and then divide by 3. So my solutions to this equation are x is 5, or x is negative 2/3. All right. So you see all those steps? Step 1, set the equation equal to 0. Step 2, factor. It may be a complex trinomial. It may be a simple trinomial. It may be a difference of squares. But you have to get it into factored form with one side of the equation equaling 0 before you can use your zero product law or property. All right. Once you do that, you set each variable factor equal to 0 and you solve. Okay. There's your assignment. Away you go.